Audio Jungle. Audio Jungle.
Hey guys, Marco here from Aviator Live CS. Welcome back to my channel. And today we will continue with the review of the Boeing 737 systems, and we will be talking about air systems. So what I have done here, I divided air systems in 3 different videos. So today we will be talking about bleed air system, and then we will talk about air conditioning system, and then pressurization system. I thought it was better to do it this way. Let me know what you think in the comments below. And today I want to give again a big thank you to Dream Aero for letting me go to the sim to sit down there with the instructors to get these videos for you. And they are located in Dubai Festival City Mall, Level G. So go there, talk to them, and they are going to explain you what you can do in the sim. And I'm pretty sure you're going to have a great time with them. Also, I want to thank Captain Pat Boone for letting me use his great Boeing 737 MRG app, which is an app that you probably want to have when you are sitting down and reviewing or studying systems. For both of them, for Dream Aero and for Boeing 737 MRG, I'm going to leave a link in the description below with their websites. So you can go there, check it out. They have really nice information there. So let's start. Let's keep reviewing these systems together, and I hope you guys enjoy this video. Okay, before we start with today's video, I want to make sure you guys know this presentation is for reference only, and it does not supersede or take the place of any written documents. Today we will be talking about the bleed air system, which is part of the air systems on the Boeing 737. And we'll start with some limitations for this system. And we talk about pressurization, and the maximum cabin differential pressure relief valves is 9.1 psi. Non-AFM operational information with either one or both engine bleed air switches on. Do not operate the air conditioning packs in high for takeoff, approach, or landing. Now we start with the system, and the purpose of the bleed air system is to collect and distribute bleed air to the systems that use bleed air. The bleed air system gets bleed air from 3 sources: the engines, the APU, and an external air card. The components and systems that use bleed air are the engine starter, air conditioning packs and pressurization, wind and engine thermal anti-icing, pressurization for the potable water tank, pressurization for the hydraulic reservoirs. So during this presentation, I'm going to try to tell you again what's the most common exam questions we can find. And one of those is this note I put in bold and black here about the sources we have for the bleed air. Also, you can get a question about the components and systems that use the bleed air. So pay attention to those components there. Now I want to show you a video about the bleed air panel on the Boeing 737. So please check this video. Okay, so guys, let's talk about the bleed air system. And here we have the bleed air panel with the lights. So if we talk about the isolation valve, it's this one here. It separates the left side and the right side of the bleed air system. The engine and APU bleed air valves control the air that goes to the bleed air system. Here we can see the engine bleed 1 and number 2. The air conditioning pack valves control air that goes to the air conditioning packs from the bleed air system. The isolation valve switch controls the isolation valve So this switch controls the isolation valve, and the engine and APU bleed air switches control the engine and APU bleed air valves. So these switches, they control those valves. This is for the engines, this is for the APU. The air conditioning pack switches control the air conditioning pack valves, so we have them here. The bleed air duct pressure indicator, as you can see here, shows the bleed air pressures for the left and the right ducts. Here you can probably you cannot see the right one, but we have two needles here, one from the left side and the other one from the right, for the right side. All of the bleed air valves are of a butterfly type. That means that they open and close quickly. Hey, let's talk about the lights we have in the bleed air panel. And we'll start from the top with the dual bleed amber light. And it is illuminated amber when the APU bleed air valve is open and engine number 1 bleed air switch is on, or APU bleed air valve and isolation valve open and engine number 2 bleed air switch on. The purpose of this light is to advise the crew of possible situations that may back pressure the APU. So we should avoid engine thrust above idle. We'll continue with the ram door full open light, 2 lights, and it indicates that the related ram door is in full open position. Now we'll continue with the pack light. The pack light is illuminated amber, and it indicates that the left pack trip off or failure of both primary and standby pack controls. Now, during master caution recall here, if it comes on, it indicates a failure of either primary or standby pack control. Extinguishes when the master caution is reset. So if the light comes on and we press the master caution here, right there, and the light should extinguish. Now we'll continue with the wind body overheat light, and it is illuminated amber to indicate an overheat from bleed air duct leak in left engine strut, left inboard wind leading edge, left air conditioning bay, kill beam, or APU bleed air duct. If we go to the bleed trip off light, it's illuminated amber when there is excessive engine bleed air temperature or pressure, left engine bleed air valve closes automatically, and reset is required. Okay, now let's talk about the engine bleed system supply. And here you can see the diagram we can find in volume in FCON volume 2. And this says the engine bleed air is obtained from the 5th and 9th stages of the compressor section. So this arrow is pointing to the 5th stage, you can see it here, and this one is the 9th stage. When the 5th stage low pressure bleed air is insufficient for the bleed air system requirements, the high stage valve modulates open to maintain adequate bleed air pressure. So the high stage valve is here. So this valve is the one modulating open to maintain the adequate bleed air pressure. During takeoff, climb, and most cruise conditions, low pressure bleed air from the 5th stage is adequate and the high stage valve remains closed. Engine bleed air valves. The engine bleed air valve acts as a pressure regulator and shut-off valve. Here we can see the engine bleed air valve. Now these PRSOVs, they are butterfly type valves, and they control the flow of bleed air to the system. This valve is DC activated and is pressure operated. And there are a few conditions that close this PRSOV. They are when we pull the fire switch, when the engine bleed air switch is off, when we have a bleed trip off light, that means an over temperature and over pressure. We'll check that in the next slides. And starting the engine 1 valve open, engine 1 PRSOV closes. With the engine bleed air switch on, the valve maintains proper system operating pressure and reduces bleed air outflow in response to high bleed air temperature. Now, let's check this video and we will talk about the isolation valve, which we can see here in the panel right here, and we will explain about it in this video. Okay, let's talk about the isolation valve switch. The isolation valve switch has 3 positions, as we can see here. It has auto, close, and open. With this switch in the open position, the valve is always open and the left and right of the bleed air systems are connected. With the switch in the closed position here, the isolation valve is always closed and the left and right sides of the bleed air systems are separated or isolated. The normal position for the isolation valve is auto, right here. With this switch in auto, the isolation valve can be open or closed. With the pack switches in auto or high, these ones, auto or high, and the engine bleed air switches in on, the isolation valve is closed. Okay, so that's explanation about isolation valve. And here we can talk about the bleed trip sensors, which we can see them here. You see bleed trip sensors, one here and the other one is here. These bleed trip sensors illuminate the respective bleed trip off light. And this light comes on when engine bleed air temperature or pressure exceeds a predetermined limit. The respective engine bleed air valve closes automatically, and that's an exam question as well. So just remember, the respective engine bleed air valve closes automatically when we have the bleed trip off light coming on. Okay, let's talk about the duct pressure transmitters. And you can see the duct pressure gauge here. They provide bleed air pressure indications to the respective left and right pointers on the bleed air duct pressure indicator. This indicator is AC operated. Differences between the left and right duct pressure on the bleed air duct pressure indicator are considered normal as long as there is sufficient air for cabin pressurization. The bleed air system duct pressure should not exceed 60 psi, and temperature limit is 232 degrees Celsius. If we talk about the external air connection, there is an external air card source. It provides an alternate air source for engine start or air conditioning. Let's talk about the APU bleed air valve. The APU bleed air valve, which is located here, and this is a switch, it permits APU bleed air to flow to the bleed air duct. The valve closes automatically when the APU is shut down. The APU bleed air valve is DC controlled and pressure operated. With both the APU and engine bleed air valves open, so this one here and this one here. So these switches here on and open, and the engines operating at idle thrust, there is a possibility of APU bleeder back pressuring the ninth stage modulating and shut-off valve. This would cause the ninth stage valve to close. Okay, we'll talk about the wing body overheat. And the wing body overheat condition is caused by a bleeder duct leak. It is sensed by the overheat sensors located as shown in this diagram. So you can see left light sensors where they are located, and you can see the right ones where they are located. You see the numbers here, you can check it here. Now we want to talk a little bit more about this in the non-normals section here. Now, let's talk about the FCOM Volume 1 supplementary procedures, and we will talk about the no engine bleed takeoff and landing. So let's go and watch this video. Let's talk about no engine bleed takeoff and landing. And we need to do this when we need some extra thrust for takeoff, or we need some additional thrust for go around. The steps are the same, except for the landing. We need to complete these steps below 10,000 feet. And the first thing we need to do is to select the wind and the ice switch off. It's important to know that the APU has to be operative in order to do this no engine bleed takeoff and landing. If we move now to the bleeder panel here, the first thing we'll do is to complete what we call a C pattern flow. Let's see how it looks. So we'll make sure the right pack switch is in auto position, and then isolation valve switch closed, left pack switch auto, engine bleed air switch here off, APU bleeder switch on, engine bleed 2 air switch off. What we did with this sequence here is turn off the bleed from each engine, while the flow of bleed air continued to at least one pack. Now, after takeoff, we need to make sure that if an engine failure occurs, we cannot position the engine bleed air switch to on until reaching 1,500 feet or until obstacle clearance height has been obtained. And now we will complete what we call the reverse C pattern flow. And we'll start with the engine bleed 2 air switch on, APU bleed air switch off. When cabin rate of climb indicator stabilizes, engine bleed air 1 switch on, left pack auto, isolation valve auto, and right pack auto. Okay, now we will talk about the bleed air abnormal operations, and we have this explained in the following video. Now we will talk about some abnormals for the bleed air system. And when the engine bleed air exceeds pressure or temperature, we'll see the master caution coming on with the air conditioning indication. When the bleed trip off light illuminates here in the panel, we can see it here, the related engine bleed air valve closes. Okay, after the bleed air is cool, press the trip reset switch. When you press the trip reset switch, the bleed trip off light extinguishes and the related bleed valve opens. If the temperature and pressure are now less than limits, the system operates normally. Now, if the temperature or pressure are still greater than limits, the bleed trip off light illuminates again and the related bleed air valve closes. If the bleeder trip-off remains illuminated and wind anti-ice is necessary for the flight, we need to turn off the pack on the affected side. When we turn off the pack, the isolation valve will open and the bleeder system supplies air to the right side for wind anti-ice. Okay, now if we keep talking about the bleed trip off, if you guys have the MRG, you can go to the air system section and they have good information there about the bleed trip off light. You can check it out, and I can show you here what they say about this light coming on in flight. You can see that they say that the engine bleed trip off during initial climb is most likely caused by an overpressure, often after a no bleed takeoff. So they give us different options here to avoid this overpressure. One of them is selecting climb thrust prior to placing the bleed switches back to on. Reduces the probability to get such an overpressure. The other option is the duct pressure can be further reduced by selecting climb 2 in the FMC. We can see it there. And other option is selecting 1,000 feet per minute vertical speed on the MCP, or by momentarily applying anti-ice on the associated engine, provided the TAT is below 38 degrees Celsius, the aircraft is above 1,500 feet, AGL, and obstacles had been cleared. Okay, if we get the bleed trip off light and we run the non-normal checklist for this light, the condition is one or more of these occur: an engine bleeder overheat, that's what we talked about before, and an engine bleeder overpressure. So according to the checklist, the first thing we need to do is to put the wind anti-ice switch off if it is in use. Trip reset switch push. The bleed trip off light extinguishes if the bleeder temperature has cooled below limits. Number 3, so we'll see what happens. We have to choose one. Bleed trip off light stays illuminated. If this light stays illuminated, so we need to put the pack switch on the affected side off. This causes the operating pack to regulate to high flow in flight with flaps up. Avoid icing conditions where wind anti-ice is needed. The other option we have is if the bleed trip off light extinguishes. In this case, we'll go to step 4, which says wind anti-ice switch as needed. Now we have a caution here in the non-normal checklist, which says use of wind anti-ice above approximately flight level 350 may cause bleed trip off and possible loss of cabin pressure. So this is what the non-normal checklist says to do in case of the bleed trip off light illuminates. Okay, now we'll talk about the wind body overheat. And we have 2 lights here in the same panel. And these lights show that there is a duct leak in the bleed air system. The wind body overheat detection system has sensors that detect bleed air duct leaks from the bleed air system. This system monitors ducts in the wind and engine strut areas, the air conditioning bays, and the bleed duct from the APU. When the left wind body overheat light illuminates, this one here, the system has found a leak in the left side of the bleed air system, which includes the duct from the APU. And if we have the right light illuminating, the system has detected a leak in the right side of the bleed air system. We checked something in the MRG. It has really good information there. They say that the chances for having a double leak, one on each side, they are extremely remote, except for structural damage after some kind of impact. So that's the reason why the non-normal checklist does not direct to switching off any bleed or pack. And it also says that the leak in the left or the right side tubing can be confirmed by a low pressure in the bleeder duct pressure indicator, which is this one here. When the wind body overheat amber light illuminates, no valves close automatically. Okay guys, that's the end of the video. I hope you liked it. If you did, please give me a thumbs up. If you're not subscribed to my channel yet, please do it now and hit the bell so you will know once I upload a new video. Just remember, I'm planning to upload videos every week. So next week we will continue with the air conditioning system. If you think these videos could be useful for somebody else, please share them. That's going to help me a lot to grow this channel. I hope to see you guys next week, and until then, please take care and see you soon. And I want to thank again Fadi for helping me and doing these videos for you guys. And hopefully I'll see you next time for this next system.
We're waiting for you.
Okay, thank you guys.